Scientific notation. By the end of this, you should be able to say, I can use scientific notation to express large and small numbers. We use scientific notation as sort of a shorthand to get rid of lots of zeros when we have very big numbers and very small numbers. So when we have very big numbers like the distance between here and the nearest star not in our solar system, or very small numbers like the weight of an atom. So when scientific notation always looks the same. It's notation meaning it's a way of writing things. So the way of writing things is always a number times 10 to a power. And that number, called the coefficient, is always between 1 and 10. In other words, when we have the number 1 and 345 thousandths, times 10 to the second, this number is written in scientific notation. There's one digit before the decimal point, times 10 to a certain power. However, the number 13.45 times 10 to the first power is not in scientific notation because we have two digits before the decimal point instead of just one. So for looking at the next one, looking at the next part of the page, to write numbers, we've already written a lot of numbers from scientific notation in standard form. We just haven't called it scientific notation before. So we know that when you multiply a number times 10, it moves the decimal point to the right one place. So if we're going to multiply by 4 tens, we're going to have to move the decimal point 4 places to the right. So 3.67, we move it once, twice gets us to after the 7. 2 more times is that 4 places, and so we have 367,000. We have to add 2 zeros to the end, and that would be our answer. For the next one, we need to move the decimal point 6 places to the right. So once, twice gets us to after the 8. 3, 4, 5, 6 means we have to add 4 zeros to the end. So 4, 6, 8. And then 4 more zeros means that we have 4,680,000 is the same as this original number written in scientific notation. When we have negative exponents, that we know that really means reciprocal or division, so we're going to move the decimal point to the left. So this one we need to move to the left 6 places. So once gets us before the 7. We need 5 more times, so we're going to add 5 zeros. So 78 10,000,000ths is what is the same as our number written in scientific notation. And that would be your answer. For the next one, we move the decimal point to the left 5 places. So we're going to move it once, gets me before the 4. 2, 3, 4, 5 means I have to add 4 zeros. Notice this 0 before the decimal point doesn't count as one of those zeros. So we have 4 zeros and then 4013, and that would be our answer. For the next one, to write numbers into scientific notation, it's slightly more tricky, but as long as you pay attention to the details and do step by step, you won't have any problem with it. So the first part of scientific notation is we need to write our number times 10 to the something. We need to write the number with the decimal point in the correct spot. And that correct spot is always between the first and the second digits that aren't zeros. So in this case, it's going to be 2.45. And we're going to drop the 0 because the whole point of scientific notation is to get rid of those extra zeros. Now, the second part of scientific notation is always times 10. And we need an exponent. We need to figure out what exponent do we need to use that when I multiply it times 2.45 gives me 2,450 again. So I moved the decimal point between the 2 and the 4 to get it back to its end, to its original spot. I need to move it 3 places to the right. That means my exponent has to be a positive 3, because multiplying by 3 tens is going to move the decimal point 3 places to the right. So here's my number written in scientific notation. For the next one, we have 4.56. I'm going to put my decimal point between the first and the second digits. Times 10. Always, always, always times 10. And now, if I move the decimal point from back to its original spot, I need to move it 1, 2, 3, 4, 5 places to the right my exponent's going to be positive 5. And that would be my answer in scientific notation, 4.56 times 10 to the 5th power. Same thing for really small numbers that are really close to 0. So we need the decimal point to be between the first two non-zero digits. So we're going to have 3.45 times 10 to a certain power. So we need to move that decimal point back to its original spot. So 1, 2, 3, 4, 5 places, but I need to move it to the left this time, so I need my exponent to be negative 5. So 3 45 times 10 to the negative 5 is the same as my original number in standard form. Last example, I need to put the decimal point between the first two non-zero digits, so that's going to be between the 6 and the 7. Times 10, always times 10. Now I need to move it from after the 6 back to its original spot. So 1, 2, 3, 4, 5, 6, 7 places to the left. Notice not to the front of the problem, to the where the decimal point started. So it's 7 places to the left, so my exponent is going to have to be negative 7. And that is my answer. That's writing numbers in scientific notation. Take your time, be careful, always talk yourself through the problem, and you won't have any issues.